Alright, section 1.5 on page 50 talks about limits of a function. So limits is getting very close to a value but never reaching. So let me start with an example. Let f of x equal x minus 1 over x squared minus 1. Find the limit of f of x as x approaches 1. And the way we write it, x with an arrow 1. So if I pick If I pick 1, I want to pick a value close to 1. Let's say somebody say, well, let's go with 0. So this is x minus 1 over x squared minus 1 as 0. If I put x equals 0, well, since I'm going to be plugging a lot of functions into that, I want to show you a trick that you could use in a calculator. So if you put 0, you should get f of 0 to equal 0 minus 1 over 0 squared minus 1. That is 1 over 1, which is 1. Then I want to get closer. I want x approaches 1. So let's say you pick 0.5. Now what we want 0.5 plugged in there. 0.5 minus 1 over 0.5 squared minus 1. So since I'm going to be using the same function, there's a nice trick on a calculator I want to show you. If you run this calculator, and if you are to plug in the first value you're evaluating is 0, enter. Now what the calculator did, it stored in this answer a 0. Now, instead of inputting the function over and over, if you use, wherever you see an x, you use answer divided by the answer, and you square it, minus 1. If you plug it in, you'll get a 1, as you see. If you plug in 0.5, 0.5 minus 1 is negative 0.5 over 0.025, so that's 0.97. Instead of doing all of this, just go to the calculator. Instead of saying, let's take 0.5 minus 1 divided by 0.5 squared minus 1. Instead of doing that, well, you could do this. If you go back, if you go and put 0.5 enter, now it's stored 0.5 in the answer. If you go back 1, 2, some calculators use this arrow to go back. And if you go back to there, the answer, now it's storing 0.5 in each of those, and it's giving me the answer as 2/3, which is 0.666. So that is 0.666 continuous. That's what that means. So now, if I pick a value closer, let's say I go to 0.9. Now you might be asking, well, when are you going to stop? I'll stop when these numbers are very close to each other. 1 and 0.6 are nowhere close. So I'll go on at 0.9. Instead of plugging 0.9 again, and I'm going to show you, instead of saying 0.9 minus 1 divided by 0.9 squared minus 1, there's the answer, 10 over 19. All what I have to do is plug in 0.9 enter. Now it's stored in my answer. Go back up. It stored 0.9 in there. And guess what? I'll get 10 over 19. And if I hit decimal, 0.52. Let me copy that. Whoa! It sure didn't like that. Next number up, well, I want to get closer to 1. What's a number closer to 1? So I started with 0. That's 1 unit away. A half, that's half a unit away. 0.9. How about 0.99? So again, instead of taking 0.99 minus 1 divided by 0.99 squared, if I use my calculator properly, and you could do that in exams, go back and input, there's the answer. 0.5 So now I'm getting somewhere. Again, it was a bit confusing in the beginning because you're not sure what you're doing or when you're going to stop. I'm going to stop when the y values level off. First y value was a 1, then 0.666, that doesn't mean much. Then 0.5, that's good because it's close to 0.6. Now do you notice it's accurate to one decimal place? What if I go for 0.999? Plug it in. So for now, things are confusing. Bear with it. We're just trying to figure out if this is leveling off. And do you see that this is now accurate to 2 decimal places? There. Do you see the y value is 0.5? The idea is to get those to be very close. How about 0.9999? Oops. 0.9. Okay. So if I go back, there. Now, if I was to ask you, what do you think the y is going to be as I get closer and closer to 1? What would you say? Well, if you look at it, the y value is coming out to be 0.5000. What do you think will happen if I pick a 0.99999? I'm getting a 0.50000. Now it's accurate to 4 decimals. So this is how I would write it. Since I looked at 1 and I picked points on the left, I say as x approaches 1, the negative indicate you're approaching 1 from the left side. F of x approaches, it seems to be 0.5000, which is about a half. Now what? Let me do the same thing, but now let me pick values to the right of 1. So let's say I start with 2. Again, instead of plugging 2 minus 1 over 2 squared minus 1, that's 1 over 3. That is 0.3333. It's much easier just to say take 2 and plug it in and evaluate it. There it is. That means this is 0.33333. Again, let the calculator do the work. No point in you re-inputting this every time. But 2 is very far from 1. How about 1.5? Well, if I go in there and I plug in 1.5, evaluate it, I'm getting 0.4. Well, that's pretty good. What if I go in there and I plug in 1.1? .476. 190. Well, it's leveling off a bit. That's good. How about 1.01? Evaluate it. 0.4975. How about 1.001? So again, when do you stop? Until you're confident that if I do this more, it's not going to do me any good. The number is going to be the same as what I'm getting right now. So I'm getting this to be 0.499. Let me try one more. Do you see how close these numbers are to each other? If I round this number, what do you think I'm going to get? So the idea of the limit is extremely important. How do you find the limit? You plug in numbers. Do you see I'm getting this accurate? Is there a point in plug-in maybe another 0 in there closer to 1.49? What do you think that number is? It seems as x approaches 1, but in this case from the right side of 1. So you're picking those numbers bigger than 1 to the right. F of x is approaching, again, if you round this, it looks like it's a half. So normally this is how it works. If f of x is defined when x is near, notice we never ever used 1. We didn't use 1 anywhere in there or there. So close to 1. If f of x is defined when x is near the number a, then we say, instead of writing this, we say the limit as x approaches 1 of f of x equals a 1/2. That's normally how we do it. New notation, but we're going to use it for a while, so it's redundant. So this reads, the limit of f of x as x approaches a equals L. Means, this is what this means that if we choose x values very close to a on either side, on both sides, but never at 1 in our case, then f of x values will become very close to L. It's very important that those two match. If they don't match, then the limit doesn't work. Okay, that was one problem. Let's do another one. Use a table of values to estimate the value of the following limits. Here, I'm trying to figure out, again, how do you find the limit? You pick values from the left and from the right. If they match, you say that's what the limit is. If they don't match, the limit doesn't exist. So I'm looking at x, and I'm looking at x to the 5th plus 1 over x to the 9th plus 1. So I need points. Let's go from the left. Number to the left of negative 1. Negative 2 is far, we already know. How about negative 1.1? If I go for negative 1.1, now I need to change this function. So I'll take negative and make sure that you use this negative, not that negative. Negative 1, enter. Now it's stored. If I click answer, there it is. Now, if I take parentheses, take the negative 1, which is my answer, and raise it to the 5th power, and add 1 to it. Divided by, take the answer again, and now raise it to the 9th power, and add 1. Oops, there was an error. What was the error? The error was I used a negative 1, didn't I? We can't use a negative 1. Remember, the whole idea. So this is the idea. If I have a fuse that burns at 3 voltages, right? 3 volts. How close can I get to 3 without it? I know if I put 3 in, it's going to break. But how close can I get to 3 without it breaking? So it's kind of like you're getting very close but never reach. I use -1. You can't use -1. You could use numbers close to -1. So I should have put -1.1. So if I take -1.1, enter. Now if I evaluate, there it is. Oops, that's not it. Okay. -1, -1.1. I'm making the same mistake. There we go. So let me double check. It is. Now if I take my answer raised to the 9th plus 1 divided by the answer, that was a 5th, wasn't it? If I take the answer raised to the 9th, and if I take -1.01, so one value is always useless. You need few values to really see whether they're leveling off next to each other or not. Okay. How about -1.001? Oh, much better. It's leveling off next to a number. It looks like a 0.5 so far, but it doesn't look like a half. It could be, but I'm not sure. How about -1.0001? Very good. It looks like it's going to level off next to, it looks like 0.55555. Not a half. Maybe I'll do one more just to confirm. I'm suspicious, but I'm not sure. So I'm going to plug in one more. I'm going to try -1.00001. Yep. So it looks like from the left, from what I see, it looks like this is approaching a 0.55555 overlay. Okay. So far I got that much. Now let me shift this a bit. X and x to the 5th plus 1 over x to the 9th plus 1. So now going from the right of -1, well, I'm going to go with -0.9. Now, what's the hope? The hope is that it gets the same value, -0.9. That's a very good start because that number is close to 0.5. So, anytime I'm taking a limit, I must do two values, one from the left, one from the right. And the left and the right must match. If they don't match, there is no limit. We say the limit doesn't exist. How about if I take a -0.99? Very good. Again, that's because it's leveling off. It looks like a 0.555. Now, if not, I'll just say the limit doesn't exist and I'm done. So how would a limit exist? A limit exists if the limit from the right equals the limit from the left. How would a limit not exist? A limit does not exist if the limit from the left does not equal the limit from the right. A very easy definition. How about a negative 0.999? And how about a negative 0.999? Well, I am confident that it's going to be a 0.5555. That's simple. So here, I notice that's the case. I say the limit as x approaches negative 1 of x to the fifth plus, you could write f of x if you wish. And there it is. And the reason I could say that because the limits from the left equal the limits from the right. That's always the case. Okay, I'm gonna finish this in the next video.